Hello class, welcome to the next video, and we're going to go over some of the stuff we already learned this unit and add in the real world situations to it. So today is called slope, aka, or also known as, rate of change. So remember we had a bunch of names for slope. When we first did the video I said, hey, it's m, hey, it's rate of change, it's change in y over change in x, it's rise over run, but we really only did rise over run or change in y over change in x. And then the next video, we talked about it being m because we talked a lot about the equation. And today we're going to talk about it being a rate of change a lot more. And it's used mainly to talk about real world things. In the real world, we don't say the slope of a lot of things. We usually refer to them as a rate of change. Like when you're driving in a car, there are two things, there's two variables that make up your speed or rate of change, and it is the distance that you traveled compared to the time it takes to travel. And those two comparisons can be like an x and a y, and the way they interact or their relationship is called the rate of change. And together in math we call that slope, because when you graph that rate of change it does look like a slope, like the side of a mountain. So today we're going to be doing some things we've done before, but with some context, some real information behind it. So you can see in this first one, there's two graphs here, and one of them is the heart rate of someone who is at normal resting position, and then the next one says heart rate before diving. I'm guessing that means like skydiving. So you can imagine your heart probably beats a lot faster, as this one does right here. So if you look, the two variables, your x and y, are not called x and y this time. They named them after what they represent. T instead of x for time. B instead of y for number of beats. So they do that a lot of time. They switch x and y. X and y is used when we don't know what we're talking about, but we usually use letters that mean something when we know what we're talking about. So you can see at the bottom, time goes by minutes in a normal way, 1, 2, 3 on both graphs. But then beats per minute, you get a lot of heartbeats in a minute. So it really wouldn't make sense to use 1, 2, 3, 4. We'd be going really, really, really far up the graph in order to hit how many beats you have in 1 minute. Just 1 minute alone. So they chose a different scale. They said, hey, every square is actually worth 50 beats. So then it goes 50, 100, 150. And that worked this time. So you can see we're still going to do rise over run. But this time we just need to be really careful about the scale. So we're going to take the 2 points they gave us, these two here. There's one at 0, 0, and I'm going to rise 3 blocks, but that doesn't mean I put the number 3 on top. I would be really wrong if I put 3, because that would be 3 beats for every 2 minutes. And I don't think you can live like that. Instead, 3 blocks means 150. So that's my number on top. So 150 over, and now I'm going 2 blocks, and that really does mean 2 minutes. So my beats per minute, right now I have 150 beats per 2 minutes. But I want to simplify that so I can get beats per minute. And that would be 75. It's half of 150. Per 1 minute. So 75 beats per minute. Over here we're going to do the same thing, but this time we're going to have to go up to the 400 and then over 2. And that makes sense. Before you go skydiving, your heart's racing a little bit. So that's 400 beats per 2 minutes, which is 200 beats per minute, so it more than doubled. So you have to watch that. The state likes to give you questions where the scale is different than what you might be expecting. So always pay close attention to what the boxes actually represent. Alright, and as we go through here, what I decided to do, because this is stuff you already kind of know, you know the basics of all of this, is I took last year's state test, all the questions they released, and took anything out that had anything to do with slope being a rate of change, or slope in a different way than we've done it before. So a lot of them are real world situations, but some of them are just kind of normal numbers asked in a different way. So I thought we would kind of explore some of those other types of questions. Alright, here's the first one. This would have been on the first day of the 3-day test, number 16. And when you write this, you do want to write the question. If you want to write the whole question, be my guest, but you can also summarize this in your notes. You don't have to write every single word. It says the cost to rent a paddle boat in the city park includes an initial fee of $7 plus $3.50 per hour. Which equation models the relationship between the total cost y and the number of hours x that the paddle boat is rented? So they want an equation. They want an equation of a line. And we know that equations of lines look like this. Y equals mx plus b. We talked about that all last class. And we also know that m represents slope, which has another name, rate of change. So it's the rate. Out of these two numbers they gave us, 7 and 350, which one of those is a rate, which is something that changes over time? That's the 350. So it's pretty obvious that we want the 350 in the slope part of that equation, which means it's going to be 350 times x. And that makes sense too, because if x is the number of hours, I want to multiply that by how much money it costs per one of those hours. Alright, and then it says, with the 7 that we didn't use, it says it's an initial fee. In other words, it doesn't change. It's always going to be 7. I could go for 1,000,000 hours. It's still going to be another $7. So I want to just add that on, and that's called the constant. Also, initial, meaning right up front, you pay it right away, is kind of like what we start with when we graph. We know it's going to start at 7 and then climb from there. Very much like what we do with the y-intercept. So that should go into the y-intercept spot. Now this one had choices, but I didn't want you to start looking at the choices right away. So let's see if anything matches what we have. Alright, and the only thing I forgot is the y equals part, if you notice that. So this is y is the total cost, would be this plus this. So does that match anything? Yeah, they just didn't put the 0 on, but this is it right here. Sometimes I like to do that. I'd like to hide the choices and figure out the answer so that I'm not influenced by the choices. Alright, here's another one. It is number 29. I think that's still the first day. It says, during an experiment, the temperature of a substance increased at a constant rate of 3 degrees Celsius per hour. That's an important thing. And it even says constant rate of 3 degrees Celsius per hour. That's 3 degrees per 1 hour. Which graph represents this relationship? Okay. Looks like they all start at 20 degrees Celsius and then increase. So they all increase. We can't get rid of anything based on that alone. So now I want the one that every time the temperature goes up 3 degrees, time ticks off 1 hour. So let's see. This one here has a dot there, and it looks like it goes up 1 degree for every 3 hours. That's the opposite of what we want. So it can't be that one. And again, if you're doing notes, you probably shouldn't write every single one of these down. You should, when we figure out the answer, write that one so that it matches the question. Alright, this one here looks like it's got dots along the line there. This goes up 2 degrees for every 1 hour. That's 2 over 1. So it's similar to what we want, but not what we want. Over here we have, looks like it goes up 2 degrees for every 2 hours. That's further from what we want. That's only a 1 degree per hour rate. But over here we have going up 3 degrees over 1 hour. That's exactly what we want. We wanted to match that one, and here is our right answer. So again, those are the kind of questions the state likes to ask. They like to ask about slope and rate of change without you really knowing that they mean slope. Alright, here's another question, and this is the second day. This is when you could use a calculator if you want, but we really don't need it for this one. It says function 1 is defined by the equation y equals 3/4 x plus 1. So there's something written in y equals mx plus b form. And function 2 is represented by the graph below. So there's two separate things. This equation is not this graphed. So that's one thing. If people don't read carefully, they think those two things are the same, and they're not. There's function 1 and function 2. So the question is, which statement about the functions is true? And all of them have to do with rate of change, which we know means slope, and y-intercept, which we just did a day about. You know, we did that in the last video. We know what y-intercept is. We know that this right here is the y-intercept for the line, and this is the y-intercept for the equation. So since we already took care of that part, and I covered it up enough, I can't tell if that's plus or minus. That's plus. Okay. Erased way too much. There we go. So up here, y-intercept equals 1. Down here, y-intercept equals, it looks like -3. You can see that the scale is different. It goes by 2's. So -3. Does any of the choices, can we eliminate them based on that? Let's see. Part A says function 1 has a greater rate of change and a greater y-intercept. Function 1 does have a greater y-intercept, so that one's still okay. B says the same thing. C, though, says in function 2 has the greater y-intercept. That's not true, so we can actually get rid of C right now, because it says that function 2 has a bigger y-intercept, and that's not true. Alright, so it looks like we need to know something about the rate of change. Rate of change, or slope, of the first one, since it's already in the format we want, it's nice, is 3/4. So I know m is 3/4. Down here, I got to do a little digging. It doesn't just pop out at me. So you got to find some spots where you can find coordinates. Looks like that's a good one. It looks like maybe there's another good one. I guess I'll use those. I'm not exactly positive of the rest of them here. I'm going to rise this much, run this much. That's a rise of 1, 2, 3, 4, 5. And run of 1, 2, 3, 4, 5, 6, 7, 8. Ugh. That's ugly. M equals 5/8. But they really tried to make this tough on you here. It's hard to compare fractions when they don't have the same denominator. So 3/4 is the same as 6/8. So 6/8 and 5/8, if I'm comparing those, this is the bigger one. And also we already decided that y-intercept was also the bigger one. So function 1 has the bigger y-intercept and slope. And I think choice A is the one that says that. Function 1 has the greater rate of change and greater y-intercept. Oh, and I just realized I could have got rid of 2, or part B, choice B. Well, I'm not going back and fixing my narration for that. So hopefully you caught it and I didn't. And now we both know. Alright, so part A says function 1 has, not part A, choice A says function 1 has the greater rate of change and greater y-intercept, and that's what we figured out. So that's a lot of work for a part 1 problem, and sometimes we try to get that, we try to warn our students of that. Sometimes we just want to answer so fast that we don't really put the time in. These are worth just as much as a lot of the part 2s. So you really got to be careful. Take your time with these part 1s. Alright, here's one more. This is number 57. This is getting into the short answer type question. So this one does not have choices. It says a certain function is defined as, and they put it in kind of Englishy terms, multiply the input by -3/4, then add 2. Graph that function on the coordinate plane below. Okay, well, when they use the word input, I think to myself, x values. because those are the things I can plug into an equation to get output, which is like the y value. So I'm going to just pick a couple values for x that I can test this out on. 0 is a good one. That's always fun because when I multiply it by -3/4, it's still 0. And then when I add 2, my output is 2. Okay, so now I want to pick some more x values. And I want to be careful how I pick, because when I multiply by a -3/4, I want something that's a multiple of 4, and I'll show you why. So I'm actually going to pick 4. And I'll do the work down here. So 4 times -3/4, I'm doing what it told me to do, plus 2. And then these cancel, the 4's cancel, and I'm left with -3 plus 2. And that will give me -1. So when I go all the way over to 4, that's here at -1. And just to get one more point in, I want to make sure I do this right. I'm going to choose 8. So that means -3/4. I'm moving the parenthesis. I really should have the parenthesis like this, so showing you what I'm plugging into the equation. Notice this is where the x would normally go. -3/4 times 8, so I cancel these, but there's 2 left because 8 divided by 4 is 2. And I multiply what's left, -6 plus 2. And that would be -4. So I move over to 8 and I go 1, 2, 3, 4 down. And they're all in a line, which is what I wanted. You'll use a ruler though, not be curvy like that. And there's the function. It doesn't say you have to label, and I don't think you probably would have had any points taken off, because that would require you knowing how to make the equation from that. But you can see, if I just, instead of putting 8 and 4 and 0 in, if I just made it x, that's the equation. Y equals this. So we can go that extra step, even though I don't think they needed you to, and label the line. Alright, we have one more. I promise I will be done with this quickly. It says a customer is comparing 2 different text message plans at Cellular Bargains. He wants to find out which plan allows the most text messages for the same cost. And they named this one the pay per text plan. Charges $10 a month and then 10 cents for each text message. Write a function that models this plan, stating what your variables represent. So there's no room for that, but that's okay. We want the rate first. The rate is 10 cents for each text message. So we say the total cost is going to be 10 cents per text message. So I'm making x be my number of texts. Y is going to be the total cost. And that makes sense. Remember, we talked about slope as a rate, and 10 cents is the rate. And then we're going to add $10 to that, because there's just $10 a month no matter what. So this is representing 1 month. Is 10 cents per text plus $10. We're comparing that to one that they've already graphed for us. And you can see they basically gave you the answer to what x and y are, because that's what they labeled the sides: cost of the plan, number of texts. For our pay per text plan, it starts off at 10 and goes up 10 cents every text. Now they did their scale very differently. The next, they went by 20s every time. One of the easiest ways to do this is to pick somewhere at the end 200. So and do a what if. Like, hey, what if I made 200 texts? Well, that would be 10 cents times 200 plus another $10. So you can use a calculator for this part too. You can do 10 cents times 200. I know that that's just moves the decimal over once, so that's 20 bucks plus 10 bucks, and that's 30. So I know at 200 texts, this plan costs $30 and actually did not plan on picking the one that met the other line. This would keep going up. That's a terrible looking line. And actually that's the next question. It says, how many text messages would result in the same cost per month for the two plans? Well, we just did it. It's 200. If you picked something else, for instance, you could just really carefully draw with your ruler a line, and where they meet is where the two plans would cost the same. Alright, I'm going to end it here. I'm sorry that this video is a good chunk of time, but hopefully it made a lot of sense, and that you don't need to, I went slow enough, you don't need to pause it that much. Alright, we'll see you when we see you.